except for the month of June, when it was minus 11%, July was plus 9, August plus 15, September may approach 0, minus 2 right now. So there's nothing unusual to discuss about this monsoon, but I'm going to take the opportunity to make a very radical proposal. My criticism is that we have been focusing too much on extreme events. All the papers published, all the work done is on droughts and floods. Okay, but they constitute not just 30% of the last 154 years of data we have. 70% are normal. We're not asking why they are normal. Nobody's asking, yes, it should be normal. I mean, that is not right. I think if you examine these 70 years, you'll find there are many years, two of the external factors, mostly SSTs, they're going against each other, they're cancelling out. Okay, just luck. But it has not been examined. I've not seen a single paper, I may have missed something, of the 124 years of data, which is normal. I've not seen an analysis showing, is it because SH everywhere was normal, or there were opposing phases. Now, 20 years ago, I remember Dr. Sahai published paper, I was at the time editor in the map, and that created some interest. But that was looking at the last 150 years of SST and rainfall and trying to find how many places in the world are connected. It was not that successful. And also, sometimes I found in that analysis, there were a few little points where there were high correlation. It doesn't make sense. Okay. Now, that's a challenge we face. We won't really look at rainfall leadership spatial factors for the last 150 years, then you have to trust on SSTs. Okay. Now, I don't think we can trust SSTs before 1970 because there were no satellites. There are a few ships here and there. Depends on ships opportunity, not regular ships. So the data, especially in the Equatorial Pacific as well as Indian Ocean, there are very few data points. Okay, so I don't know how they reconstruct this by various clever techniques of today, but one has what done. Well, I'll come back to this now because at the end of the talk, I'll talk about something unusual that happened last week. The paper came, it is absolutely mind-boggling. It's not relevant to this discussion, but everyone should read it. The paper says the reconstruction of global mean temperature for the last 485 million years. Okay, it's absolutely mind-boggling. Okay, you should look at it because this is the new way proxy data has been combined with model. Okay, so proxy cannot give you continuous data, no chance. Okay, proxy cannot give you spatially uniform data, very difficult. These guys are combined it. I mean, this is work of hundreds of scientists, and paper just appeared. I'm sure a lot of criticism about it, but it is remarkable that today we can talk about global mean temperature for the last 400 million years. Now, it's not relevant to monsoon, definitely, but all of you should look at it. I've been obsessed with it because I've been talking about climate change for the last 37 years. Okay? And most of the time, I got a lot of criticism, not from average person, they are all much more aware of climate change, by very intelligent people. You are who is an astronomer. He told me you're wasting your time. All the warming is due to sun. Just keep it aside. Now, this piece of work demonstrates clearly that although sun's intensity increased over the last 5 million years, it has not had as much impact as carbon dioxide. Okay, so it took me many years to convince people that CO2 is the controller of global mean temperature. Okay, not sun. But it was not easy to. Astronomers are very smart people. They can argue various ways. So I had difficulty convincing them 10, 20 years back. Today, I think most people are convinced because the evidence of climate change is in front of you. You don't have to believe them. Okay, so this is my point that all the analysis you see is about droughts and floods, very few analysis of normal years, where 2 or 3 parameters may work against each other. Okay? There's of course one piece of work by Srinivasan. We combined Indian Ocean dipole and Monsoon showed how they contradict each other. And further, arithmetic some work, I'll talk about that a little later. Okay, now just let's look at spatial pattern, district-wise, which I like because of very high resolution, and show the classical drought condition that has existed in this region for the last 10, 20 years. Okay? And this being opposite to this is sort of accepted. So this is the pattern of this year. Most 70% of districts got 6% and only 24% got below normal. Forecast is from NCMRW sent by Ravi to me. These are the forecasts for these 4 months of this year. And these are the data right now I have still longer. September is not yet come. And I would say that was good. Okay. Yes, they got the late onset here correctly, but they didn't get this part right. Okay. And this is very interesting. I'll talk about it later. Come to July, they got it too high. High rainfall. Okay. In reality, it rained much more in Central India and Karnataka. So that, although they were right about above normal rainfall, location was wrong. Come to August, again, I would say the location is much to the east and the south. Okay. This may be right because it's still raining in many parts of North India. Now, this is the June, July, August forecast that was there. And this I'm deliberately putting entropy analysis on how accurate it is to find out if this is there. It's not there, not that much. And yeah, this one is closer to what we saw in terms of video. Okay, now let's look at the probability forecast from IMD, that is on this side, and the actual product from IMD up to 20th September. I would say, by and large, it's correct, above normal rainfall here. This part is not captured. This is also slightly off, and there is a hint of especially below normal. Now let's look at the time series, which I already discussed the previous weeks. The only interesting part is what happened in August. Up to July 31st, both last year this thing was very close. Okay? Then we had a long break in August, which did not occur here. September 8 compensated somewhat, and this is not compensated. That's only difference for these 2 years. And remember, last year was El Nino, and this was supposed to be a La Nina, but it is a neutral year. Okay, now let's look at cumulative rainfall in various parts of India. Northwest India started poorly because of the delayed onset there, but then it made up and then it's slightly above normal. These blockings, as you saw in the spatial pattern, except for a short time when the monsoon progress was delayed, it had a good time. The once monsoon came, it went completely below normal. And this is comparison between Central India and South India. We were very lucky. We were positive right through. This is most unusual. You look at all the data for Karnataka, every reservoir is full. Okay? Very rare event. And if you look at the water vapor, which is my favorite variable, it has already started showing the withdrawal of monsoon. This thing is not developing. This is the oceanic season seen through water vapor. It's coming very clearly. And the next few weeks, we'll see this developing and whole system moving to the south. Okay, so September rainfall in relation to September 3.4 is falling right on the zero line. You know, 3.2 is close to zero, minus something, and rainfall also is going to be 4 or 5% or maybe zero. So September rainfall is following this mean and very good. Now let's look at forecast from ECMWF. I will first show the forecast in April, and they make every month they make. April, they predicted already June is below normal, July above normal, August above normal, September normal. All this came out right. Then quantitative levels, they were roughly correct. Not exactly. This is April.
June looks like abnormal.
Yeah.
The June looks like abnormal.
What?
The June forecast looks abnormal, not big. Only the heading is bad.
Yeah. I will get it.
What I mean is that the June forecast looks abnormal.
No, this is April forecast. April, I'll show you. This is April. I'll take off.
April.
Yeah, I'm just showing how they are changing. This is April and this is June. Okay. So in June, they correctly got the, like this. In April, they didn't get. They were a little bit, no. So June, I would say June forecast, July, August, all commodity. This may be wrong now because you're getting close to zero now. Yeah, this could be wrong. And I'm sure this because in that point they were learning. I'm sure of that. Okay, now we do the normal evaluation of all the forecasts that IMD has made on the last week of May. They got the all India right within the range. Now this I think is unfair. They're not giving me a range. They're saying above 106. I don't know why. I mean, when you make a forecast, you have to give a range, right? So they are saying above 106, so they are right because they're not giving a range. But normally their range is plus or minus 4%. So I suppose correct. This is wrong. Okay. They thought it is normal, it is above normal. So the point to remember is both last year and this year forecast was wrong. Last year's rain was not predicted. This year's high rainfall was not predicted. Still, we have to figure out why. Okay. Then September, everybody said 10% was normal, maybe close to 100%, maybe less. Then if you look at spatial pattern, I would say they were quite right. Not numerically, but the fact that they got Northeast India low correct, North India high correct, within their range. This one is one-sided. I don't know what to say about it. And these two are one-sided, so I don't know how to evaluate it. You want to give a range. You would say that forecast range is typically this is 12% here, right? Then this was 106 to 150, then it will be right. Okay. So they got this pattern overall right. Okay. So one point about is that they were more confident about the rainfall being more than 4% than climate. So that is the which they can claim. They were more confident that it would be above normal. Maybe for the wrong reason because everybody thought of learning. Now all of them thought it didn't come. Okay, now let's look at SkyMet. SkyMet has given again error bars, so I don't know what to say about it. So I would say they were okay. Roughly, this one also is okay. This is wrong, like IMD, and this is also wrong. So both SkyMet and IMD pretty much similar. Now let's just review the last 10 years of discussion we had, Monsoon discussion. The only thing what looking at here is, remember that only 2015 was below normal rating. Just came within. Okay. And you look at the previous 10 years, you'll find 6 to 7 years below normal, not droughts, but below normal. That's what in my discussed paper, one paper published earlier said that drought long-term decline is due to land sea contrast and a high temperature over equatorial Indian Ocean. The next paper said the increase is on account of just because of this difference. The previous 10 years, there are a lot of below normal rainfall. In this year, this 10 years, you can call this below normal, or this below normal, but all the others are at the normal or below normal. So that was the difference. Now I'm going to compare 2016 with 2024 because we were thinking that this year we go from El Nino to La Nina. That was everybody's prediction. And that was so that it also. So these two are comparable in terms of temporal variation. Okay? So let's see. And the issue really here is to compare 2016, June is almost same within the error of measurement. July, same within the error of measurement. August is the only difference. August is all by 6 to 6 millimeters, okay, not a minor amount. Okay. And September, I mean, it may do better. I estimated 160, and this is the higher. So the question is, what happened in August? Well, both were transition from El Nino to La Nina, and we'll see the actual numbers of the event. But I want you to keep this in mind. My main claim is this is the difference. So the positive PDO in 2016 and the negative PDO in 2024. Okay, that's the only reason I can see. And you look at the evolution of, you can see that in 2016, here, it's already negative in June, July, August. Okay, and it crossed minus 0.5 in July, August, September, and went on. But this year, we are probably close to zero here, or maybe very minus value. So this is a big difference in terms of the way it was. Remember that it is surprising. It was 2.5 in January. There's only 1.8. Yeah.
Why are you not considering Indian Ocean like
Indian Ocean? Why are you not considering Indian Ocean dipole response to monsoon? Does not.
okay. It is the
If you look at the DMI prediction, it is so bad, it's not worth looking at. On the other hand, then so well, 0.4, 0.5, you want to do the higher. DMI, see, there's more ocean here, too, okay? There's no long time scale delay between ocean and land. So you see all major impact of IoT on the monsoon was in August and September, not earlier. So there's no forecast for it. And secondly, the cause and effect is not clear. It is with others. And compared to best mechanisms wanted to really clarify the rule. And I'll show you my personal belief that the so-called Indian Ocean basin mode is more important than IoT. Because if the Indian Ocean is warmer than normal, more water vapor comes from here. That's the one. Okay. Now this is my picture. Again, I'm basically on NOAA website. Cannot be accurate. I'm comparing August of 2016 or 2024. I want to see the big difference here. Because of the video effect, which is not in the tropics, but closer to subtropics. That is a big difference from these two. Okay? And this long negative anomaly. Part of it belongs to your NP2, right? Yeah, so that has had some effect. Okay, the only trouble with PDO is, I'm not a great fan of PDO because PDO has a long history. I discussed this a couple of years back in Monsoon Cafe. It was started only by people in fisheries. In the Pacific, there was a huge decline in fisheries at some point, mainly due to overfishing, not due to climate change. But you know, you can always blame everything on climate change. So not to the Aruba, series of debates on. So they developed index, and then people in climate community came in. So there are all kinds of difference available. You can look up PDO, PDV, and IPO. There are all kinds of names, very confusing. Okay? But I stick to PDO because that's available in the NOAA website. The key point I want to make is something strange happened in 2016 from July to August. PDO changed sign. Now let me tell you, I don't like this. I don't like a so-called parameter which is supposed to tell you decadal variability varies so much from month to month. I don't know, somebody has explained to me, how can you come up with a decadal variability index that doesn't, it can change sign, but once it changes, it remains that way for some long time, right? But unfortunately, these are done by EOFs and other techniques. You have no control over it. So this to me is a problem. It changed sign, I have no problem. But again, it changed sign. Okay? And then again it went back. So obviously some either noise or some other problem that I don't know what it is. But here, this year is continuously negative. Okay? I don't think it's going to change sign. So I am negative. I don't see it's going to change sign. So definitely this year was a negative PDO without a La Nina. 2016 was a positive PDO till July, and La Nina already started. So that is the difference which needs to be examined. Now I come back to Arindam's work, which I wanted to pursue, but he has not done it. So this is the paper he published in Monsoon. In India is very highly correlated with this index. What is SST index? Consisting of two specific regions away from the equator, 3.44, and EIO equal to IOD. Okay. Now, this impressed me very much because I have never seen anybody getting 0.91 correlation. That's not possible in our field. Okay. So, but it turns out that it is sensitive to the period you choose, right? I think Arindam chose 82 to 2014, right? Yeah. And that period looks very well. If you look at some of the period it goes on, we don't know what. So my advice to Arindam is you should put few more indices there because Atlantic, as we did, last year, a nice talk by Kaushik Mishra, Atlantic plays a role, but not every year. I'm talking about equatorial Atlantic. So that's where the problem comes. If you depend only on correlation, then even which occur once in 10 years may not easily give you a number. But the reason why I think why I like this method, you can add a few more, and then this method will tell you that this region, which is all normal rainfall, okay, are years when these are acting against each other, or these two are against each other. One is going up and down. So that understanding is not there in any other method. That Indian monsoon influenced by Pacific, by Indian Ocean, I'm sure also Atlantic, and in the normal years, it just turns out that there are some cancellation going on. Okay, now I come to the question already raised. If you look at the prediction skill of 3.4, Indian Ocean Basin, and DMI, DMI is the lowest. Okay, it's well 0.4 around this time, and then just rapidly goes down. The IOB is blue in color, it maintains pretty high skill. Okay, this is a lead time, and of course, 3.1 also maintains. So that's why I think 3.4 and IOB have more value than DMI. Now, as monsoon is ending now, suddenly 3.1 has gone negative. It has become minus 0.48 2 days back. Okay? So it's going to go down. So the funny part is the international community will declare this year as a La Nina. I'm sure about that. Because it will go to minus 0.5, 0.5, 0.5, 3 months is required, done. So I want all of you who read papers very careful. Those who do work outside India, they use NDF, November, December, January as the basis for defining La Nina and El Nino. We should not do that. October, November, December is irrelevant to us as far as monsoon is concerned. Okay, so to me, be careful because I've seen many papers. If you look carefully, they use NDJ. To me, that is irrelevant to discussion on monsoon. Okay? It is relevant if you're going to say that monsoon caused El Nino, La Nina. That is relevant. Otherwise, it is meaningless. Okay, now I want to remind you of this paper I talked about, the curious case of El Nino that never happened in 1974, which nice paper, please read it. It's a very popular paper. So I would say this is as far as we are concerned, not others. It is a year where the La Nina did not appear as expected. Okay? So this is the counterpart to what happened in 74, 50 years later. Now, it's appearing, I can see that this is really now developing, so not there earlier. So I'm sure it will go all the way to beyond, it's already touched the date line, go beyond that. But that thing is still there. That part is really interesting and strong. positive anomaly there is still there. Now, why are people having problem with La Nina? There's a nice account by Chiodi and Harrison. Have argued that people use westerly wind anomaly for the onset of El Nino. Okay? They say similar analysis was done for La Nina. Okay? For La Nina, easterly wind anomaly, not westerly. Okay? And they argue these have been overlooked because they are not obvious in the wind time series. Okay? And you must examine the stress, not the wind. As far as impact of atmosphere was concerned, not the wind, it's the stress which is important. So their work was somewhere has not got sufficient coverage. Okay, so they define an easterly wind surge so that they can calculate that. It's short-lived compared to westerly. Okay, and cooling across the waveguide persists for 2 to 3 months. Okay, just as the westerly wind. So this is the reason I think many models they didn't have. So this is essentially a challenge in the case of El Nino and La Nina itself. It is driven by winds, and wind, as all of you know, are chaotic. It's a atmospheric phenomenon, not ocean. It's chaotic, and you can totally miss it in your forecast. Okay? Now, again, it's not stress sufficiently by people. I'll give an example I saw, not published in a PhD thesis. Okay, before that, I'll just show you the various forecasts starting from February. Okay? In February, except for GFDL, which whom I have great respect because Manabe is there, almost all of them said by May, June, July, the minus 0.5, all were wrong in February. Okay. Then you look at May, still all of them said by September, available minus 0.5 does not happen, except for GFDL. GFDL was right. GFDL got the right number almost minus 0.4 around this week. Okay. Then you look at September, this is the future now. To next April, all of them are saying that there will be a fairly strong La Nina for 3-4 months and it will recover to become neutral. Except GFDL, which is really peak La Nina and then it will come back by January. Okay. So that is the forecast as of today. Now, what's the forecast from ECMWF? This was in May. Okay. And May, they predicted that by August, minus 0.4, September also minus 0.5. I think they are quite accurate compared to all the other people. Okay, now let's ask another reason why there's a problem. This comes from a paper by, I think, paper correctly? Yeah. Okay. So the point is the slope of this line. See, you're comparing here with the water volume, which I've discussed many times. The slope of this line is much more positive in El Nino domain than La Nina domain. Because for a given water volume positive anomaly, this slope is larger. Here you see it's pretty bad. I don't know how you can draw lines through it. This doesn't make sense. The other problem, they get La Nina, and that's why pretty more difficult. Okay, so this point has been made by which a long time back. In spite of amazing progress in the last 40 years, we still do not understand what triggers El Nino. Is it westerly wind burst or something else? And high and low heat content, that's the deep thermocline, is necessary but not sufficient. So this is one still people are discussing, and that's the point which is making. But this is interesting because I can tell you, I was really impressed by the work that Mark Kane did more than 40 years ago. Okay? And I can tell you as a moral story, sometimes the graphics completely seduces you. You think, wow, great, but be careful. Today's graphics can do wonders. Not deliberately, but I'll give you an example. This one, this is a Nature paper, published in 2004. This is 140-year prediction, continuous, by the Keynes Zodiac model. Okay, I mean, you see that, but wow, problem is solved. they figured out El Nino prediction, and they come out right. 148 years, they must have got at least 30 El Nino. They got it right. But be careful, because when you use such a long time series, you are compressing a short-term error. You don't see it's there. You look carefully, you'll see there are many, many places they got the numbers wrong. But in the big picture, it's right. Nobody is trying to fool you there. The big picture is right. Yes, we have a fairly good idea of what was El Nino, but you want a first prediction 6 months in advance is not guaranteed. So that's a point you have to remember. Okay. Now that comes out in the paper. The same paper, they are actually giving you the RMS error. Okay? But this figure is not that interesting. So you don't see. So RMS error for a 6-month lag is 0.5 degrees. Okay? That's not surprising. All the models are around 0.5 degree error. That's a part of the chaotic nature of El Nino. Okay? Now, this is the thesis I like very much. Baxter saw it. So in this thesis, Sarah Larson ran the coupled model. She got El Nino nicely. Then gave climatological winds. El Nino disappeared. So it's a beautiful demonstration of how sensitive El Nino is to the wind forces. It's obvious when people say what we all knew it, but nothing like showing it cleanly using a model in which you give the actual wind as well as the climate wind and show that as syndical climatological there is no oscillation. So that is to me a very nice demonstration of this. This should be a textbook really, so that everyone understands this. Now there's a problem in IPCC. They're concerned about what will happen to El Nino in the future. All of us are concerned. If El Nino becomes stronger, India is in trouble, right? So all the IPCC models say there are more El Nino-like states as climate bomb. Okay? Observations show exactly opposite. Last 10 years, we had one El Nino. Okay? So something is still wrong in terms of understanding how global warming affects El Nino. Okay? The models are saying something, others say something else, still not resolved in spite of all the AI and all the high-resolution models we have still not understood the problem. So we are getting more and more non-analytic conditions. Now I'll come to the last week presentation by Kaushik Mishra. It's a very interesting paper. We say Indian Ocean dipole is Atlantic Nino. I didn't realize that. Okay? So they are showing that what happens in the Indian Ocean ultimately affects the Atlantic. Okay? I'm still, these papers are read carefully because everybody is talking about atmospheric bridge. Because Atlantic and Indian are not connected easily. The whole Africa there. So all of them are predicting atmospheric bridge. And it worries me because there is no clear physical mechanism except they are drawn nice arrows showing this and that. The arrows don't believe in arrows. They're nice cartoons. Everyone does. Doesn't prove that. To prove that, you have to actually do tough experiments like the one we showed. They should make Indian Ocean climatological and demonstrate that Atlantic doesn't appear. Then I believe it. Not by correlation and vague arguments, throwing nice arrows. See, a lot of people do that. Cartooning is very popular now. It attracts your audience. But this is interesting result. And then this is a cartoon I'm talking about. This is from work by Monsoon, right there. So it's a recent paper showing how El Nino affects Atlantic Nino. So this is another view now. And so they're saying both through the Rossby wave here and through here, forecast both affect Atlantic and Nino. Okay. And there's a nice paper by R.K. Yadav from IIT Pune, how Atlantic Nino modulates Indian monsoon. Okay. So there you use model to make a point. But they're also going to be very skeptical. Let's first ask whether that model gets the monsoon right. Okay. Then we can look at it. Now, there are people doing another way of doing it. They look at the Indian monsoon index, subtract the ENSO correlation part, and the remaining they correlate with, I'm sorry, this is, yeah, the remaining, I'm sorry, yeah, the residue they correlate with Atlantic and Atlantic is playing a role. Okay? That's another way. Again, I don't know how significant these results are. So because ENSO effect is so large, you have to remove it. But in removing it, you make an assumption of linear dependence on these two, which is in our case questionable. Now, this is the cold and the warm phase of the Atlantic Nino, okay? And so people have looked at how these two phases affect the Indian monsoon. And this there. So they're claiming that during the this cold minus warm. So in the cold phase of the Atlantic Nino, we get more rainfall in Rajasthan in this region, okay? And less rainfall in Peninsular India and northeast. So maybe some of the pattern is related to that. Now, before I go on to the topic, I want to mention this. Everyone in the analysis they are doing, they are assuming that circulation drives the rainfall. Okay? But here's a nice paper I want to read. It's a paper where only on satellite data, and they're very careful. I like the word apparent. They don't want to be too sure about it. They're saying there's an apparent timeline between Ola maxima and the surface changes such that the maximum circulation occurs 5 days after Ola maximum. Okay? So the argument is it is Ola it's affecting the wind and not vice versa. So to me, this is a very important paper. It's worth looking at. It's based only on atmospheric infrared sounder. So people should examine it and see whether it's valid. Okay. Now I will talk about a few things which are new now. I mentioned it, but I want to go to more detail. So all the discussion we have had on monsoon is based on what I call Eulerian framework. We have our equation written in Eulerian field, and we analyze it. But that is not. We want to know how much rainfall fell in India and where it came from. You have to be in the Lagrangian framework, not Eulerian. But it is more difficult. Nobody wants to do it. Few people have done it, and slowly that community is building up. There's a paper by Day and Dole. I think he did a PhD in Sweden, and now he's I think in the IIT. IIT Bhubaneswar, right? Yeah. So he has done a very nice piece of work. Please go through it, and he divides the regions around India into 6 parts. This he calls local. Local is a little too big for my liking. It goes all in Tibet. Okay? Then Arabian Sea, we have Central Southern Indian Ocean, entire of the 70 east. Okay, it's very large, and then west, remote. Now the reason I'm showing you this is you talk to anyone who is wedded to synoptic meteorology, they will think from Bay of Bengal. So a system from Bay of Bengal. Water vapor does not come from Bay of Bengal. But anyway, Krishnamurti said this a long time back. He's a great guy, K. Krishnamurti. So this guy has shown that very nicely. Okay, look at this table. Okay, unfortunately, I don't know why he quotes rainfall in sweat loops. Okay, maybe it's ocean number. So it is a rainfall in millicubic per second. So the bit, but we can convert. That's not a good problem for comprehension. Convert sweat loops to millicubic per day. Okay, you can convert it all this. So what does it show? June. This doesn't make sense. The month of June, largest contribution comes from local. Local means you operate from the land. Okay? Now, this looks odd, but that's the reason for it. In the month of June, the land is very hot. When the rain happens, in the soil. Okay? So it's possible that right. The next highest is Central and Southern Indian Ocean, 0.16. Arabian Sea next 0.08. Bay of Bengal is almost nothing, 0.02. So Bay of Bengal water vapor plays no role if you believe this analysis. biofuels should be out that the systems come from Bay of Bengal, the hot paper comes from elsewhere. Okay? To me, this is so important that this should completely change the way we do research. See, lot of time and effort was spent in coordinating Indian monsoon with Arabian Sea, with Bay of Bengal, Bay of Bengal project almost. But everybody ignored the southern Indian Ocean. Okay? Maybe there's no data or some reason. But this shows that that is the dominant factor, and it in July goes up as the Somali that strengthens, this increases further. Okay? So does the local goes on slightly. And Arabian Sea is not bad, but Bay of Bengal is gone. Nothing. Okay? So Bay of Bengal all through is almost nothing. And it is the domination of the below the equator water vapor. And only in September when the jet becomes that it comes down. This to me is a very interesting thought. Please go through it. There's a lot more stuff in there. I only put out what is easy to show in a slide. Okay. So to me, our understanding of monsoon should be based on where does the water vapor come from. Okay. That is the basis of our understanding. Now to make the point even more stronger, he has done a time series of these various sources. Okay. Now, it's not confusing. This one is ignore all that. The key point is all the internal variability in these 10 years comes from non-local, this one, that is below the equator. So all the changes in rainfall you see is coming not from Arabian Sea, this one, and Bay of Bengal is right below. Remote, all the other parts of none of them are changing. Okay? The only thing is changing is PSIO, and that is reflected in the final value. Okay? So all the variation in Indian Ocean rainfall is because of how much water it came from the southern Indian Ocean. To me, this is the absolutely revolutionary idea. This should make us rethink understanding of what role is southern Indian Ocean playing in the Indian monsoon. Okay, now finally I'm going to end with the topic as part of it. This is a paper I saw last week, completely baffled me. 485 million in history of Earth's surface temperature. Okay? Now, the smartest about this group of people is they knew that proxy construction is very tough. It's one of the toughest fields to deal with because you have to go wherever the data is. Data is highly variable in time and is not available everywhere. But they took, and what amazed me, today there are 10,000 proxy data available to all of you. 10,000, not one or two. Okay. So these guys are very good team, both a huge team involved in it, although only 6 authors are there. All the data was collected, and then they found that because the proxy data does not cover most of the world, you can't get global wind temperature. So you have to use model to help you. Now, in the last 20 years, there has been huge progress in our ability to model past climate. This is because models have got better and better, and computers have become faster and faster. And if you recall, Chetan did the work based on the output of NCAR's model, which was run for 20,000 years, okay? Continuously, no breaks. So now there are many people who run many other situations going back 100 million years, 12 million years. Of course, short period, cannot do the whole period, obviously. You do short sections. All the data is available, and that is assimilated into the proxy. So this is the first reanalysis product for the last 485 million years. To me, this is a revolution. It's going to change the way you think, look at anything. Okay? So this paper, it just came out last week. I'm sure you're going to get lots of news about it because it says something very, very, what do you call, frightening. What is that? They're showing in the past 40 million years, Earth temperature varied 11 degrees and 30 degrees. Okay? Now, present temperature is around 50 degrees, global mean. Okay? So a huge range. Okay? Now, not surprising because they are going back to 45 million. There was a time when carbon dioxide was 1,600 ppm, long time back. Now, I don't know how many of you, those of you who have taken my course know that we have very good data about carbon dioxide in the ice core. But ice core is only 1 million years. So these guys have been able to extract CO2 from ocean floors. It's very complicated. You don't want to read those papers. A lot of chemistry, I don't understand it. The animals which do photosynthesis in the ocean take the carbon dioxide from the dissolved CO2 in the ocean. While doing, they take one isotope better than another isotope. For example, there is C12 and C13. C12 is lighter, C13 is heavier. So in this process of taking CO2, they prefer the lighter one always. That's the logic. Okay. So based on that, I don't know how accurate that data is, pretty accurate, they are able to not only find out how much CO2 is in the ocean, because how much of CO2 comes into the animal depends on total CO2 in the ocean at that time. So they are able to do all that very complex things. And so this is the piece of work which I think demands a lot of attention. Okay. Now this is the time series of the last 485 million years along with the error bar. Okay. Error bar is quite large, about 4-5 degrees. Can't help it. It's a very tough subject. But for the first time, we have some idea about how Earth temperature varies from the present value of 15 degrees all the way to 36 at some point. Okay. So this is not the end of it. They also come up and make a prediction for how carbon dioxide will affect temperature. Okay. Because they point out that in the last 40 years, solar energy continuously increased. Because all of us are starting to star, it's a nuclear reactor, and it is getting stronger and stronger. And starting from the origin of the Earth to today, it has gone up by 40%. Okay. So the last of a billion years, it has gone up by at least 5 to 10%. Now, of course, there are problems. I don't want to say that they're good here. It's a tough subject. They are comparing their product, which is the analysis product, with the actual proxy data. There are errors of the order of 10 degrees. Okay? I don't know who is right, because proxy data has problems. I can tell you that. Proxy data is full of assumptions. Because you have to make assumptions that that proxy, its behavior is same as what it is today. Nobody can prove that. For example, you look at distribution of certain animals in the ocean. And today, you know that in colder ocean, some species are there, in the some species there. Based on that, you construct the connection between the number of species and the temperature. But how do you know they're the same 1 million? You can't do that. But the great progress in this field in the last 30 years is what's called multi-proxy. You should not believe one proxy. One proxy is unreliable. Now, people have become so sophisticated, there's so much money has been poured in, that for each of the data in that black line, there are 4 or 5 proxies, not one proxy. Okay? So my gut feeling is that they cannot be too wrong. One proxy can go wrong. All the 3 proxies cannot go wrong at the same time. Okay? So to me, they are compared it in the supplementary material, by the way, not in the main text. They are showing that there's a long error. Okay? And they don't have a reason why. What?
Prior to 50 million years, they match better than now.
Yeah.
They're both equally wrong to 50 million years.
Actually, the measure. No, the ups and downs of this number. Anomalies are correct. Explaining the anomalies are quite big. There's one which is not agreeing. It has the same. So the change is pretty well captured. Actual value is not.
Now, I would imagine that the data closer to now should be more reliable.
Yes, when they proxy data, very often they can't get data up to the present time. So they are only cheap portion. Not they're only low data. Things are shut down, get compacted. So proxy data problem is you can see what's happening in the ocean. But when you want to deep ocean and take it out all the ocean, it's not easy to do. Okay, now this is the most important picture. Based on the data of the last 400 million years, they are plotting the global mean temperature with CO2 This is a log scale over there. So they're saying that over this long period, the temperature of the Earth is logarithmically related to carbon dioxide. Okay? This was about the radiation knew it, of course, but people didn't believe us. Now there is an empirical proof that temperature is logarithmically dependent on CO2. That's to me an amazing proof. And I wanted to only look at the green line. Green line is the last 6 million years. That is the most reliable data. You go back in time, things get difficult. The other data is more, for example, take this Mesozoic, which is 6 million to 230 million. It's a vertical line and there's no correlation. I would say the green line is very impressive. And what is the problem? In IPCC, there's a term called equilibrium climate sensitivity. There is how much will the temperature change with double carbon dioxide. That's very important parameter for global negotiation. IPCC around 3 degrees, mean with range of 1.4.5. Yes, 7.6. This is going to create a huge uproar because 1.7 means we are doomed. I can tell you that. I don't want to give negative news in this kind of audience for young people. If that is true, we are pretty much finished. We mean what? Mammals, not insects. Others have survived. In the Earth's long history, even when 36 degrees, dinosaurs survived, lizards survived. There are no human beings, there are no mammals about that. A lot of people don't understand. Whenever I show such results, they say, oh, 36 is okay, we can manage. We cannot manage. We can manage only the last 30 years when the temperature was nice and constant, okay? We are lucky that we had a very unusual period of 10,000 years where temperature changed by half a degree global mean, okay? 36 is important any mammal. None of us have the ability to, outside 36, you cannot survive a long period. Remember, global mean 36. So tropics should be 40, 45. Remember that. So to me, this result is going to cause a huge uproar and people are going to challenge that paleo data. There may be a problem. Remember, this is a very tough subject. And I think I advise that they're voting out, put it out. It is published by Nature. So it will be discussed. You'll see a lot of coverage of this in the IPCC meeting now. So either models that accept that they have mistake or paleo data has a problem, one of the two. But I would argue that I would only trust the recent period. The other period data, I don't see here. You can't put any line. This shows the independent CO2. Right? I don't think I trust that. But last 6 billion, I'm impressed by their line.
I have a question.
Huh?
The problem of 11.7, right?
Huh?
So it may come because their CO2 range is very large.
Yeah.
Okay, so with the larger CO2,
Yeah.
global mean temperature is high. With a higher temperature,
Yeah.
the sensitivity of the that basically scaling, process chemical scaling is much larger at higher temperature. So that way IPCC estimation is today's climate.
Yeah, but I can tell you, I want you to only focus on, your point. I want to focus only on the green dots. Okay?
Not the same thing.
They fall on a linear line in the log linear plot. That is very impressive.
You understand that?
Huh?
Most of the dots are above 300.
Huh?
Right? So basically, the temperature is much larger than today.
You see, you can say slope can slightly change. Yeah, it can.
Yeah, the moment that when the temperature is lower, one will temperature is lower.
Yeah.
Process chemical scaling is much less compared to this because that the slope at the what temperature? At the same rising temperature, 1 degree rising temperature. Right?
Yeah.
That's why it is much less compared to.
I'll tell you, that's why I don't believe the data going back 400 million years. Take the last 50 million, in which the range is lower, 36. That I think is in a legal domain. You're right, if you go to much higher temperature, so many things are happening, but there are all of it is there, we don't know. Yeah. So, but this is the figure they have put up, and they're saying 0.72 is not a great result in terms of confidence level. Okay. So this is what they're saying. This is surprising because solar radiation has increased monotonically in the past 40 million years, but it doesn't seem to play as important a role as CO2. So they are saying changes in albedo and must have compensated for the increasing solar luminosity. Okay, now let's come back to monsoon. What's the prediction for next year? If you believe the forecast, the Darlington model is saying there will be La Nina for the next 3-4 months, then it will become neutral. Statistical model saying the no La Nina will be neutral. Okay? That's the prediction. Okay? When one model is way off, this model is not surprising. It's just way off. Okay. Now we come back to Arindam's classification. So if you're neutral this year and you're going neutral next year, you're going to be in this column. Okay? Now the problem with this column is in this 40 years of data he has, neutral to neutral. Okay, not surprising because I think it will come once in 4 years. So most of the time we are neutral to neutral. There are years the highest rainfall we are aware of in here, and the lowest rainfall also. So it's going to be difficult to predict the rainfall next year because variability is very large. Okay? So this is very interesting. And second part which is very amazing to me is look at the cluster. So 3 years of so neutral exists for a long time. Okay? Here it was even longer. Okay? So that's another point to remember that El Nino doesn't repeat every 4 years. Okay? There are periods of nothing and then suddenly you have fluctuation. So that also comes out. And so the fact that there is so much variability in rainfall in this year is shown by the fact that Arindam's confidence level for neutral to neutral being above normal is not very high, right? That's why he cannot be very confident in next year being neutral. So I would say that next year's monsoon forecast will be a challenge. Okay? It could be a flood, it could be a drought, but most probably it will be average. Okay, that topic may be different. Next year, Wednesday comes on 4th June, and I want to thank Sujata, Taranka, Prabhudra, and Sheikh for making sure that everything was organized properly. Thank you. Any other question?
Can you tell me the 2006 paper's name and its forward? On the 2006 paper, 2006 paper that is from the OLR and circulation, who was the author? OLR and circulation, there is the lag.
Yeah.
What's the author? I forgot the name.
What I said, no, it will be okay. If I remember correctly, another guy, it is in the area of certain meteorology, you may not be in touch with him, but I will. Yeah, it is Randall and Parr, well-known people who have done a lot of work on satellite data analysis. Maybe somebody next year should present this so we know how good that analysis is. Okay. Anybody on the online, any question? Okay, so we'll meet next year. Thank you.